Okay, let's continue where we left off. And talked about object orientation. I started to compare it between procedural and object-oriented languages. Looked at the object concept and the class concept, and that the class is the blueprint for the object. And looked at the fields and the members. So I call them data members. You can call them fields, variables. Probably not a good idea to call them variables. Fields is probably more common. Methods. I don't like the word messages. People like that. Methods. I don't like methods either. Data members. Members. Member functions. I don't know. Depends on the terminology. And really all it is just terminology. Talked about private, protected, package, public a little bit. And this is just an introduction to all these concepts. I have a little bit more as well as we go through the next lecture. And I think we stopped pretty much right here, actually, if I remember. It wasn't too long ago. And the error message that would be generated if we did p1.price is because we have protected, we have private here instead of public, which kind of emphasizes the point of the access methods and things of that nature. So let's talk about static for a second. Do we have volume? Okay, good. Static, only one copy of the static field exists, shared by all objects in this class. I don't know why they called it static outside of, it's not dynamic. I don't know. When I think of static, I always think of the difference between static and dynamic. But static in this particular case is basically telling us that only one copy of that particular data member. You can also have a static member function too. That only one copy of it is available, and it's available. I like to call it a class method or a class variable instead of an instance variable, because it can be shared by all instances. So it can be accessed directly from the class itself. And so this is pretty much the same concept in C or C++. When we say a class name dot the name of the data member, and if it's accessed statically like that, we can do that. Otherwise, we get an error. So static pretty much opens it up for implementation. And then so it's accessible outside of the class, but must be preceded by the class name. And here we have an example of system.out.println pencil.nextID, which is kind of different because we're not saying from pencil in terms of P1. So in this slide here, actually, this is great. I like this because I can point instead of using my arrow, instead of using my mouse. See, now this is the instance P1 of type pencil, and we're saying P1 dot something, P1 dot something. Here we're kind of breaking the rules. It looks like we're breaking the rules because we're actually using the class name pencil instead of P1. But it's static, which is how the only way you can actually access it. Otherwise, it's going to come back with an error. So kind of an interesting thing. So it's via an object belonging to the class as well. So I could say p1.nextID, or I could say pencil.nextID. It depends on how I want to change it. Static just pretty much breaks the rules for us in terms of accessing those variables. So from outside of the class, non-static fields must be accessed through the object reference if it's outside of the class. In terms of its definition. And here we have another example where we have create pencil, we have P1 again, so we have pencil.nextID ++ system out, P1.nextID, so the result is going to print out with 1. And then we have another instance that we created of the same object type, pencil P2, pencil.nextID. If we said P2, we got 2 as a result, because it's being shared by P1 and by P2. So if it was already started out with 0, it got incremented by 1 in P1. That instance actually incremented it. Now P2 incremented it again. If I went back to P1 and printed it out, it's still 2. It doesn't change. So what we're doing is basically demonstrating that we can access, modify, and use a variable from a class level that affects all instances that are created of that class simultaneously. We don't have to go back and reset anything or refresh. It's automatically refreshed for us. So this code is only for purposes of showing you the usage of static. It's really a poor design. And, well, it's very redundant. It's actually a very poor design. In fact, which brings up another point. This is the driver program. It's called Create Pencil. It shouldn't include all of this code, actually. What we should do is move as much as we can into the classes. So the classes are performing all the functionality. The main driver program is just making instances of these classes. It's just running the methods. So, you know, something about printing something out, we could do it. We're not breaking the law by doing it in the driver program. But usually you want to like run a method that says print it to the screen. And it'll format it for us. It'll run all the functionality from within the classes. So you make the classes extremely feature rich, and you make the driver program kind of lame, you know, just kind of stripped down. Because if you think about it, you only create one class, and the class gets used over and over again. And how many times you create the driver program? You know, a lot. Every time you want to use the class. For years, you'd be creating more driver programs. So it's better to put all the functionality in the class and just run the methods from the driver program. And like, you know, when do you want to do your work? So now we have another modifier I haven't talked about yet. It's called final. Once initialized, the value cannot be changed. So final basically is kind of like a constant variable. Makes it so you can't change the value. So, you know, a variable like pi, you know, for 3.14, we make it final. So once it's initialized, it's done. It can't be changed, and often used to define named constants like pi or something. So static final fields must be initialized when the class is initialized. So you want to do it when the class is created, because otherwise you can't add it. You can't put a value on it. It's already initialized. I mean, it's already finalized. And non-static final fields must be initialized when the object of the class is constructed. You know, for the same purpose, actually, for the same reasoning. So here we have fields for initialization and initialization methods for fields. Not necessary to be constant as long as you have the right type that's associated with it. In fact, here's another kind of a reiteration of a point made earlier, where we said, although this was wrong, we said F here to say this is a float value, because we have float as the price variable type. We don't actually have to do that in Java. In some other languages, we have to actually specifically say we're assigning a string to a string or a float to a float. Java doesn't actually require that, but you can put it in. There's no problem with that at all. So in this particular case here, we have the float, you know, with the F on here. We could leave it out, is what I'm saying. So it's a little bit not quite as strict. So if no initialization, then the default initial value that we're assigning determines the type of the particular variable. So we could actually have typeless variables, if you think about it. And when we assign an initial value to that variable, it's going to automatically determine the type that that variable is going to be used for. And then we can also do like typecasting and stuff like that to change one variable into another type. So. In terms of the methods, we have the method declaration. So we have two parts of the method declaration. We have the header of the method or the function. I'm not quite sure why this looks like little mailboxes or something. Those are supposed to be bullets. I'm not quite sure why it showed up that way. So we have must be consistent with the modifiers. So if it's public, private, protected, we also specify that on the methods. It's also optional. We don't actually have to say whether the method itself is going to be public or private. We could just leave it off completely. If the class is public, then the methods are going to be public by default. It's going to take the same type as the class if we have declared it, if we have specified it. Just like in terms of functions, the return type of the function is going to be the type of function in terms of how we declare it, and the method name, the parameter list of clauses, just like creating a function. And here we have types of modifiers. We have access control modifiers. Abstract, I'll talk about that in a few more minutes. The method body is empty on an abstract method. So sometimes when we know we're going to use inheritance, we can actually create a base class, make everything abstract, leave it empty. And then if it's there in the base, then it's required to be either implemented, if it's going to be used, in an inherited class that we're building from this class. And I'll show you an example of that soon when we start looking at inheritance examples. But that's the reason why we're using abstract, because we want to put it in there, but we don't necessarily want to define it at this point. Static can represent the whole class as a specific object, can only be accessed, so you can only access status fields and other static methods of the same particular class. So static again is per class. Final can't be overwritten by a subclass. So find that we use abstract, static, and final when we start looking at inheritance and start building classes from classes, because it imposes rules. It imposes things that we can actually follow. And then we have the method body that follows through. So we look at, in terms of the invocation, and this is more vocabulary for you, when we invoke a method, it's called an invocation versus an instantiation, when we create an instance of the particular class. So we invoke methods on the class. So the invocation uses the dot reference, very similar to the languages. The dot operation uses for either the methods or for the the data members, or for the member functions, depending upon what we're calling. It's the same access method. The static method outside of the class is a reference. So it's either to the class object or to a class variable. So inside a class's reference can be omitted. Non-static method, the reference must be an object reference. In terms of, and I'll show you an example of that between the static and the non-static. Here's an example, actually. What is this? Oh, this is overloading. I have another example, actually. I'll show you on my Windows partition. It's not in the slide set that will represent that. Let's talk about overloading. So in terms of overloading, class can have more than one method of the same name, and it's referred to as overloading, where we have, for example, different parameter lists that are associated with the method. So in the old days, they said, well, you can only have one function name for a function. This is when C and C++ people learned how to do main, and then you learn how all the variables had to have unique names, all the member functions or functions had to have unique names. Not quite the case, actually, in Java. Actually, not the case in C++ either. We have this thing called a constructor that's built for a class. And a constructor is nothing more than a method that invokes automatically when a new instance of the class is created. And then outside of the constructor, we have just regular old member functions. Member functions, this is an example of that. We have set price as an example. We have two functions that are different, but they have the same name. So this gives us polymorphic behavior. Actually, this is how polymorphism is built into the class structure. Because we have set price, we can give it a float, new price. Or we can say set price, we can give an instance of pencil, an object. We're sending an object to it. So we could actually run, as an example, if we made P1 for pencil, we could say P1.setPrice, send it something. Or send it something else. And then we have polymorphic behavior that occurs, actually, because depending upon what you're sending it, it's going to react differently because it's running a different function, which is how we're implementing that polymorphic type of characteristic. So how does the compiler know which method you're invoking? Well, you compare the number and the type of the parameters and matches it. It says, well, we're sending, you want to, let's say, calculate an average price. We're sending it a double, or we're sending it an integer. We're sending it something, well, it's going to find, hopefully, the matching method, and it's going to run the one that's appropriate to it. It's also another concept. Basically, the concept is also referred to as overloading. We can overload methods within the same class, and then when we look at inheritance, we can overload and overwrite methods in inherited classes that are built from base classes that also follow through kind of a similar thing. Let's see, we have parameter values. So parameters are always passed by value, and if you're not familiar with passed by value versus passed by reference, you're lucky and you don't have to worry about anything. Just take for granted that everything in Java is passed by value. But in the old days, we had to worry about, was it a reference, is it value? Because you had to worry about stuff like, what happens if you use the value that you're passing to the function inside of the function? What happens, oh my god, the entire array is going to change. The content's going to change outside of the function. Because in the old days, we had functions. It's kind of like going to Las Vegas. What happened in the function stayed in the function. If you're familiar with that Las Vegas reference, and what happens in Vegas stays in Vegas. But then again, what ended up happening is, rumors and headlines in the newspaper come back. Oh, what did I do in Vegas? Oh, here I am. Kind of like the same thing happened with C++ with references. If you sent a reference, all of a sudden it was public knowledge. It got sent everywhere. Back in Maine, they knew about the change, and the change occurred. So, believe it or not, everything's passed by value. And here we have an example of public void method 1, integer a, where we have a is equal to 6. We're going to run method 1, b, now b is equal to, b is equal to 3. So when a parameter is object reference, it is the object reference, not the object itself, that is actually getting passed. And I know we just said that everything was passed by value, not reference, but it's actually the reference to the object. So we'll see that in an example coming up to make a little bit more sense to you. But we don't actually have to worry about, because we don't have pointers, we don't have to worry about the address of, we don't have to worry about the reference. We're actually, when we send something like an object by value, it's the reference to the object, so we're actually sending the object. And it actually does create a pass by reference. So, and if you're not familiar, pass by reference actually changes the value of the memory. Pass by value doesn't. Makes a copy of it, so it stays in Vegas, actually stays in Vegas. With pass by value, it doesn't with a pass by reference by default. So here's an example of a parameter that is an object reference that's being sent. And I believe probably not this session, but the next session, the middle session, we'll look at passing objects more. At this point, don't really be concerned with it if you're not quite getting it. But what we're looking at is if you change any field of the object which the parameter refers to, the object is changed for every variable which holds a reference to this particular object in terms of the scenario that's going on. And you know what? I'm actually going to save myself a little headache and kind of skip through this because I'm going to hit it in a lot more detail with another example. And it's really kind of a more advanced topic I don't want to hit yet, so I'm going to skip it optionally. Alright, so the main method. In main method by concept that we've seen so far, the main method shows up in the driver program. And the system locates and runs the main method for the class when you run the program. So what ends up happening is you actually have to figure out which program you're going to run, because you're really running the main method or your driver. So let's say you have 3 or 4 files, and like 3 of them are classes, one of them is the main driver program. Depends on which one you type in Java space the name of the file. You actually have to make sure you type the main, because that's the one you really want to run. Although all of the other classes are kind of self-standalone classes that are going to sit there in the file system. And actually when you compile it, what ends up happening is if you compile the main, it goes back through and looks for everything else that it uses inside of main and goes ahead and checks to see if that's been compiled. If not, it'll go ahead and compile it for you. So it doesn't really matter if you put everything in one file, if you put it all in 12 different files. As soon as you compile the driver program or main, it takes care of everything else for you by default. The only thing it won't do actually is go through and see if there are changes made. So in the old days, when you ran Visual C++ or something and you compiled the program, it looked to see, did the file change? And if the file changed, then it recompiled it. Did that file change? Did that file change? Java actually doesn't do that. In fact, you can have bits and pieces of the program compiled with the rest of it not. Because the rest of it, if you think about the concept, might not necessarily be locally stored. It might be remote objects that this main is running. And as long as it can find the path and find the file, it just leaves it alone. It doesn't touch it. Which makes it more portable, but also makes it more tricky. Because let's say you did change something, but you didn't compile that particular class file. Instead, you went back and you compiled main. And I'll show you an example of how this works as well. Then what ends up happening is you have old code working with new code, and things that may have changed may not have been recompiled. So you could run into some issues. So other methods get executed when you call by main explicitly or implicitly. It must be public, static, or void. In fact, that's the data type for main. Most likely, normally you see main as void, and you see functions. This is the other thing they teach you with C++ that kind of messes you up. It's okay to have void functions. Void doesn't return a value. And when you start writing classes, sometimes you have classes that put stuff on the screen or get information. They may not necessarily return anything. And those you don't really want to specify a type for. Just make it void. So void's not a bad kind of data type to use. So getting input from the command line. As we've seen so far in main, normally we have the command line arguments. That's when you type something on the command line, space, first name, space, last name, or whatever, and information comes through on the command line, and it gets parsed in the program, gets used for something. You'll have to do this for your first program, actually. Then you're wondering, well, geez, how do you get those arguments in automatically? That's what this stuff is here, the argument information that's inside of main. In the hello world example that I showed you and all of the other examples are going to use the standard format. So although you don't really need any of this stuff, because especially if you're not taking any command line arguments, you could make it empty, leave it out. Or you could just leave it in there by default. Eventually you'll probably end up using something. So when running the Java command, you can also, just like you do in C or C++, you can pass it in, and it's done the same identical way. It's an array index that comes through, where you can pull off argument 1, argument 2, argument 3 that's passed on the command line. And here we have greetings, Jackie and Mary. Hello, Jackie and Mary. What it's doing is taking string name 1, string name 2, the command line argument, and printing it out on the screen. This is slide number 19 out of lecture number 2. You're going to need this for your first programming assignment. Because the first programming assignment is going to have you parse the command line. Take the two items. One of them is going to be a temperature. The other one's going to be a Fahrenheit or Celsius. And you're going to have to parse the information and apply it inside of the program for something, inside of the main. So just keep that in mind. Just make a mental note. Slide 19 is going to show you how to parse that out. And then obviously you can take this and combine it, and you don't necessarily have to make it a string. You can call it an integer, a double, a float. You can basically change the data type as well as you're assigning it. And I'll show you some conversion stuff as well. So what do you get? You get strings coming in. You can convert them into any type that's needed, essentially, for what you're going to do. So, modifiers of classes. So we've seen modifiers, and we've been talking about modifiers. That's the public, private, protected, abstract. Modifiers for variables, for methods, also for the class. Normally you see public class hello world. Well, you can make that private class hello world or abstract class hello world. And so the class has modifiers public, abstract, and final is what you get. You can't make it private. If you make it private, you can't use the class. It's useless. But you can, there might be a special need for the class, but private's not going to do anything. So public is what you're normally going to see. And if you don't put anything in, it's going to be public. So if you don't want to worry about access methods, in fact, you can probably get away with it for the first assignment. You don't need any of this until you get to inheritance, because then you don't have to worry about it. Public is publicly accessible. Without this modifier, a class is only accessible with its own package. So if you put public in there, it's accessible throughout all of the other classes that it might use. So think about the package as a solid directory. Like within my current directory, I can see all classes without any access method at all. If I put public in there, I can see it outside of the package too, or I can see it, wherever I need to in other classes. Abstract, if no object of the abstract class can be created. Well, actually, abstract has to be used. I don't know what that is. Abstract has to be used as the class type if you're putting abstract methods inside or abstract data. If anything inside says abstract, the class has to be abstract. And what's just funny is I see abstract on everything. Public abstract class, public abstract. And it's almost like students cut and paste examples off the internet, and everything says abstract and everything says public on it. Because public doesn't cause you any problems. It's available to everybody. And abstract, well, you might need it because something inside of the class might be abstract. But abstract only says, it can be changed. You can leave it blank. It doesn't really, and half the times when people are using abstract, they're not even using it for what it's intended to be used for. They're just putting it in. Because you're not going to get an error message if you put abstract all over the place. It's not going to do anything. It just gives you more options in the future. Whether you use those options, most of the time you're not. But public abstract, you see it everywhere for some reason. Because it opens up the door, violates all the rules, makes you able to do whatever you want. So all of the abstract methods must be implemented in the subclass if you have abstract classes, which is another interesting thing that I'll talk about when we get to inheritance. It's like if you want to make sure that the method is implemented, then you create it as abstract. We moved into this room. So, otherwise, the subclass must be declared as abstract also. So final cannot be subclassed. If it's a final, it's constant. If you remember it can't be changed once it's initiated. So if you don't want the class to be inherited, you make it final. That way, the base class stays a base class forever, cannot be inherited. So Well, it restricts you. Normally the file can contain multiple classes, but only one public one, normally. And the file name of the public class should be the same as the name of the class, which is where that comes into play, that class name and the name of the file need to match in most cases. So let's take a look here then at, what was that, was lecture 2. Lecture 3, moving right along, is going to give us a little bit more more stuff. In fact, I want to bring up an example before I start lecture 3. I just want to make sure I have this loaded correctly. Hello. There we go. All right. I'm going to talk about constructors and base classes in terms of functionality. And before I do that, let's see. Oh, there we go. I want to actually do this from a DOS level. Okay, so this is not inheritance yet. This is just regular old classes. We saw Hello World, and it was fairly basic. And it was all written in one program. Well, we didn't really have that much to it. Let me see what hello is, just to refresh my memory. Hello's going to take some arguments. I actually have these examples out on the website as well, if you're interested in, until you don't have to write all this stuff down. Now what we're going to look at is an example that has main. Maybe I can make this a little bigger so you can see it. There we go. Oh, that's bigger. There we go. So I actually called it main because, I don't know, I could call it main program or whatever you want to call it. I have boss and I have, oops, this is my inheritance. Nope, this is my employee. Good. Hold on a second. Let me just make sure I have the right example. Okay. Yes, non-inheritance example. But I want to show you a few things just to put things in reference, and then I'll go over the PowerPoint stuff because sometimes it helps to actually see the example first. So I have 3 files and it's making up a program. All 3 files are stored in the same location. They don't actually have to be. I'm not using packages yet because I don't want to get into that concept yet. The next slide, the next example will show you packages. The main program actually contains a lot of functionality it probably doesn't need to contain. But what I've done here is I've created a class main, same name as the file name, main.java. And what I've got going on here, I'm using the string arguments, I'm ticking in, but I'm not really doing anything with it, so it's no big deal. I've got employee is another class. Notice that I haven't included a package, and I'm not doing an import. Most of the time, often I see import this, import that. If it's in the same package, you don't have to import it. This comes from the old days when people used to go, you know, the header and the interface and the implementation on C++. And they used to have to put the .h's. We don't have .h's in Java, which is going to be template files or I guess template outlines without the implementation. So instead, what I've got here is absolutely nothing up there. And this doesn't actually have to be the top line. I could put spaces in here. Doesn't really matter. I'll show you packages in the next example. But this one I kind of left it out on purpose to kind of show you how this all works. I've located it all in the same directory, which is why I can do this. If I move them out and put them into different directories, and had other programmers work on different packages, or excuse me, different classes within the same package, it's going to be spread out all over the place. Then I'm going to have to use a package. Here what I'm doing is I'm making 2 instances of 2 different classes. I've got class employee and I've got class boss. And I've got those in 2 separate files. This is kind of like how you want to model your programs. Every class should be in a separate file, so I should have an employee.java and I should have a boss.java. And what I've got here is an employee, and this is how we're creating an instance, the name, just like any other data type. So if I said integer I, float j, or something, this is employee, my employee. So the type is employee, the variable name is my employee, and this is going to be equal to new employee. Interesting, because I haven't really sent it any information. I've just called the class, I've made a new instance of the class. When I do that, we're getting what's called the default constructor. And a default constructor is a method inside of the class with the same name as the class that invokes automatically when every new instance of that class is created. And I'm relying upon that default constructor to do something, maybe to initialize some variables. Here I've got two instances that I'm creating of boss. I've got boss space my boss and boss my boss 2, another one. The second one is kind of like what I did with employee. I didn't send it any information. I just said, you know, my boss. Give me a new instance. My default constructor is going to go off. And by default, you know, I can't remember if I said it or not, but the default constructor doesn't have any parameters, doesn't take on parameters. Here I'm creating another boss using a name, a salary, a level. I don't know what all that information is, but I need to know. And in order for me to call this particular and create this particular instance, I need the order and I need the values that I'm supposed to present, whether it's a float, a double, string, for each one of my parameters that I'm passing. So let's go take a look. The rest of this is just printing some stuff out to the screen. We're going to call here get name, get salary. I'll talk about that in a few minutes. And here we're just printing out some stuff. Here I'm setting an attitude level of 5 for, you know, I'm running a method called setAttitude. So let me go back out here and take a look at the boss and the employee. So here's an employee. Simple, no package or anything on this one. And I've got 2 data members, and this is kind of review is what we did before lunch here. 2 data members, string name, double salary, and I've got member functions. Here are the 3 member functions. One of them has the same name as the class, so it's going to be considered my constructor, my default constructor, because it's not taking on any parameters. That would be this one right here. And this is setting the name and setting the salary. For those of you who have experience in this, you're probably familiar with this. You're probably familiar with this. This says this object name, this object salary. When we talk about inheritance and we have super, meaning that one over there, super above us, because what we have with inheritance is we have sub and super. Super is above, sub is below. It's kind of weird because when you create a new instance, when you inherit a class from a base class, the base is on top, is super, and then you have sub. When really it should be the other way around. You think the base would be on the bottom and you grow it up this way. But the terminology is actually upside down if you think about it abstractly. You could leave the this out, because if you leave this out, then it's referring to this object, this name, this salary. Either one is going to work, but it's kind of sloppy to leave it out. But I left it out on purpose to make the example as simple as possible. So what ends up happening is what the natural progression is when you learn how to do this is you start out with the bare basics. And then you start adding in these concepts, as you know, like abstract, and you start adding in this and super and everything else. Because what it does is it kind of like makes your life easier. It cuts down and eliminates errors and basically creates a more stable environment for your program in the long run. I could actually put it here, return this name, or I could just leave it alone. And so what I've got here is a what's referred to as a constructor, because it happens when the new instance of every employee that's created. In C++, we have a copy constructor and we have a deconstructor. In Java, we don't. We just have the constructor. We just have 1 instead of 3, because we don't have dynamic memory. In the Java environment, we had a copy constructor when we wanted to send a reference by value, and we had a destructor when we were using new anywhere and we wanted to use delete. I mean, a destructor basically when the class was done, when the instance was destroyed, it would go through and work the opposite of a constructor. So the name came from, the constructor came from when the class is constructed, when the instance is constructed versus destructed versus copied. So that's where the naming is coming from, but we only have the constructor. And here we have 2 different types of methods. Here's another terminology. Depending upon whose book you get, who you follow, some people call them set and get methods. Some people call them accessors and modifiers. I actually kind of like the accessors and modifiers, but when I write them I usually use get and set. So I'm kind of playing with both. Basically what you're doing is creating two different types of methods. One that's going to get information from the user and assign it to this object's variables. Or you're going to get information from this object's variables and give it out to the main program. So you're going to get it or you're going to set it in terms of the functionality, or you're going to access or you're going to modify. There. And what are you accessing and modifying? You're accessing or modifying the variables, the data members that you have set for the class. And these particular examples you're looking at are only working with data members and member functions that are belonging to the class. We haven't talked about inheritance yet. So this is basic, bottom line, base class. Your self-composed, all-in-one class. So the employee class is kind of basic. The boss class is a little bit less trivial because it's working with two different constructors. So boss has got name, salary. Now the boss has got a level, management level, and an attitude score. So, I don't know what the attitude, we could basically rate the boss's attitude. And here we have a public boss. That would be the default constructor. It's going to set the name automatically to Mr. Boss, salary to something, entry level for the level, attitude 0. And then we have another constructor. So this one would not be considered or not be called the default because the default's the only one that has nothing. That one, if we didn't do anything at all, that one's going to go off. The next one, this one's going to execute if we send it a string, a double, a string, and an integer. If we send it in the wrong order, we're going to get an error message because it's not going to know. But we could set multiple constructors with different orders. We can actually figure out all these different 4 combinations and there's 16 different methods and actually come up with a foolproof way of setting the variables if we wanted to think about it. Kind of useless, kind of senseless, because you're going to remember what order you're going to send them in, hopefully. But you could theoretically make the class polymorphic that way, so it could just take anything it wanted to and it would know what order, depending upon what order you sent it in. Although you might have a problem with those 2 strings, which string is which, I might have some logic there. And then we have the same kind of thing again. We have a get salary, get attitude, set attitude, and it demonstrates the get and the set concept. And you might notice that the set attitude is void. As I mentioned before, it's okay to use the void because I'm not returning anything. I'm just setting information. And when I call the function, I'm not expecting anything to come back. So the less communication, see, in the old days in the C++ world, we said integer this. And we never used void on anything because we always wanted to return something. But there was no overhead for that. We didn't have to worry about information being put out into the environment that's being passed. If we didn't use it, it went away because of scope rules. Java, everything you return is taking up a piece of memory. If you're not returning it, don't return it. Leave it void. Because in this particular case, it makes your program run faster. Depends on what you're returning, how often you're returning, how many times that function's running. But you could overuse the concept, return it when it's not needed, and then your program's going to run slower than if you just used void and didn't return it. Because it's taking it until the garbage collection occurs. And yeah, garbage collection happens automatically, but do you want the can to be overfilled all over the street before before the JVM comes in to clean it up? Because it takes up more room. So, I don't know. Long story short, it makes your program run slower, so don't return it unless you need to. So here's what happens, actually. So I'm going to do this without the Eclipse method, and I'm going to show you something that's interesting just to demonstrate the point. I'm going to make sure I don't have any class files. Whoops, there are no class files. That's good. So I'm going to forget about hello world, but I've got boss.java, employee.java, and main.java. If I type in javac and I type in main.java, it's going to come back and it's going to, hopefully not going to give me any errors or anything. there it goes, it came back. Now, if I type in directory, let's see, directories. Well, you can see it here. Directory star.class. How's that? Now I've got boss.class, employee.class, main.class. I didn't ask for main. Excuse me, I didn't ask for boss or employee, and there's no, well, outside of 2 instances being created inside of main. That's where the compiler came back and said, wait a minute, we need boss and we need employee. But if you remember, I added this to, let's see, I'm going to go back here. Boss I didn't change, I don't think. I didn't change boss when I was playing around. I didn't change main either. Oops. No, I don't want to change that. But I did, I added this to the employee class, if you remember. If I go ahead and save this, and now if I run back through and I run the same command as I did before, oops, it's going to find a current, it's going to find a.class boss and a.class employee, and it's going to assume it's current. So if I run, I don't get a new one. I get the old one that was created. So my point is, it's not a bad practice to delete all the class files or recompile everything. If you're working in this type of small environment, what ends up happening in the future when we start working with inheritance and stuff is we have a .class file. Right? We have boss. We're not changing boss. We don't have boss. We're assuming it's not going to be changed. We leave it alone. We only compile what we're working on, which is the driver program. We leave all the other classes the same, which is where you get that reuse from. So it's kind of dangerous working in this kind of environment just to compile main without compiling the rest of them. But if I compile main, it does compile if the rest of them don't exist. But if I make a change to one of the existing ones and I don't specifically recompile it, it's not going to be recompiled. I'm still getting the older version, which is one of the kind of the problems you'll end up with noticing when you start looking at the functionality and you go, I thought I changed that. You know, then I didn't change that. I left it alone. I mean, I did change it, but I saved it, but I didn't compile it. So it's kind of interesting to see what actually does get compiled and what doesn't when you're working with these examples. Now, if I ran them in Eclipse, believe it or not, I get the same behavior. If it's already compiled, if it already exists in object code, it's not going to be recompiled. It's going to essentially be left the same. So as Eclipse loads, I'll make this environment a little less labor intense. I have another program actually that takes and looks at the arguments and parses out. The way that you would, this is actually an example that's out on the website that would help you. It's called Hello. The way that you would essentially work with that first programming assignment, and we'll take a look at that in a few minutes, is if you were taking the command line arguments in, you could say argument 0 is going to be the name, and argument 1, or the next one's going to be the age. If this particular program is saying, hello, type in your name, space, your age, it's taking a string and it's taking an integer, and now we're using and I have some lecture material on parse integer, parse float. What we're doing is actually taking this integer as an object, and we're running a dot parse integer on it to take out this and assign it to, so we're taking from the object integer, we're going to parse an integer out of this parameter that we're sending to this method parse integer. To say take this string, turn it into an integer, and assign it to age. Which is kind of interesting because this is the one, points out another example of what's different with Java versus C or C++ as well in terms of the variables, in terms of what an integer is, what an age is. Everything's an object. So you can take an integer dot parse as an object type. So if integer age, you created an integer type variable and you called it age, it's really of an object type integer because everything's an object. And everything can be treated as an object. So if you run from integer as an object dot parse integer, what you're really doing is taking, turn this into an integer. essentially. So it's a way of doing typecasting, actually. But it's not really typecasting because you're running a method to change, on the object to change it into what it needs to be. So it's kind of an interesting difference. So anyway, this example here is going to show you how to parse that input, which is you're probably going to need for that first assignment. And when I get done with here, I'll show you the first assignment. Yeah.
So from that, if condition should be in the first line of the method. So what if I call a method, if I execute that method, say Java hello, and I don't pass any argument. So
it's going to come back with an error message, actually, because
it will throw an unpointed exception. It will never come there.
Yeah, it's going to come back with an exception. You're right.
So
the
condition that you have there, the if condition, I guess that should be in the first line of the method.
Yeah, you're right. It's bad design. Yeah, because this is going to throw an IO exception. Because if you, in fact, here I'll show it to you. I'll show you too. It's actually not going to catch, this exception isn't going to work. It's really bad exception handling. What's it called? Hello? Let me just save the sucker. Hold on. It's going to throw a Java runtime error. So if I type in Java C, I need to compile it because it's not compiled. Hello.java. Oops. If I spelt it right. There we go. Let me make this a little bigger so you can see what I'm doing. Alright, so I compiled that example we just looked at. If I actually typed in Java space hello and didn't give it anything, it's going to throw a runtime exception. Here it is, an exception in thread. Because it expected the array index was out of bounds 0. It didn't get anything. But if I typed in as example, hello, Barbara, and I left out the age, only gave it 1 instead of 2, my error checking, it's going to throw an exception. All right, let's see, wait a minute. 1, age, wrong one, but wrong type, input string instead of, okay. So the only way I can get it is if I put in 12, 12, 11. Now it's going to say usage because I have 2. It actually got what it wanted, but I had put in 2 numbers instead of 1 number, so it's not equal. The length was more than 2, but it was of the right. I put in a string followed by an integer. So this is actually kind of a good example of bad programming practice because although there was an attempt made to do exception handling, as you can see, the runtime environment wasn't too happy with what it got several times. Yeah.
We are using integer. We are defining the type for the values as integer. So why do we need to put parsing as a typecast method?
Because when you get it in, it's coming automatically as a string. The arguments that are coming in from the command line are by default string. So you have to parse the integer out of that. It's almost like saying, if you remember the old days of typecasting with int inside of brackets right before the variable. You can still do that actually in Java, but to specifically specify that you want an integer out of that string. And it'll actually take everything and just take the integer value out of it. It'll parse it out. If you have extra characters in there that aren't really part of the integer, if it said like 11 F E T or something, and I said something else in there, it would take out the 11. Huh?
ASCII values, would it take ASCII values?
It would be ignored, is what I'm trying to say. You can actually parse out characters as well from strings, and it's not going to ignore. It's just going to take the character, or 2 characters, or how many characters you basically specified. So, actually, this is not a bad idea to show you how the JVM. These messages are coming from the Java runtime environment because it's not when I compiled it; is when I was running the program, and the exceptions are going to be essentially in the running thread of what we're looking at in terms of the array index out of bound or the too many parameters or something of that nature. So, any other questions before I continue? Okay. Oops. I didn't see any hands. I put my head down before I actually looked. I'm like, okay. All right. So let's take a look at assignment number 1, actually, because this. I'll leave that up for a second. This brings up a good point. Let's see. Oops, no, we don't want that. I think I have it actually. I have assignment number 1 actually here. The interesting thing is I kind of break this out a little bit differently when I run it from the weekday classes because I can like hit topic by topic because we're doing all of it in once. I'm kind of skipping around a little bit, but hopefully you can follow the logic. If not, ask questions. Okay, so before next time, after today's lectures, this is what your goal is. Now, if you're brand new at programming, you're probably not going to want to take on this first. You're going to you get yourself a copy of the DDL and DDL text, run through a couple Hello World programs, run through some of the examples I have on the website, watch the tutorials. Then you're going to try and hit this. This isn't actually that bad. It's not bad at all, personally. So, what are we looking at? You're going to create a temperature class, okay, just like boss and employee. And it's going to have two fields, or data members, you want to call them. A temperature value, it's probably going to be a float number. Could be a double. Now, here's how you want to approach the assignments. I want you to implement the concept. You can use your own creative ingenuity, academic freedom, to make modifications as you see fit. Like, if you don't like floats, you can work with doubles. I don't care. It's not... The way that you're graded on this is, did you actually put together a temperature class? Yeah, and did you actually implement the functionality that was being asked for? Okay, so a float, okay, a character for the scale, that makes sense. Unless you want to use Fahrenheit and Celsius, you can have the person type it out, although I always mistype it, so, I mean, or you can just say C or F. So make sure that these two fields can only be accessed through the accessor methods outside of the class. What does that mean? You're going to have to make an accessor and a modifier, or set a get, something. So you can set the value of the variables and get the values of the variables outside of the class. You don't want to say my temperature, my temperature, equals new temperature, and then go my temperature dot value. That would be accessing it outside. So you want to use the class to set the value for the temperature and whether it's Celsius or whether it's Fahrenheit. Okay. Also, in order to accomplish that, you're going to have to make those variables private. So theoretically, that's what you should do to make them. If you made them public and then inside you used and created methods, that's fine. But theoretically, it would be wrong. So private is the way you want to actually say that those data members are defined. And then you're going to create some constructors. So the class should have 4 constructors. So we all know what a constructor is right now. I just showed you. It's the same name as the class name. Which one is the default? The one that doesn't take on parameters. We can have 4. Same name. Different level, different number of parameters, different order. Whatever order you want is fine. 1 for each instance field. Assume 0 degrees if no value is specified, and Celsius if no scale is specified. So, one of them is going to say new temperature, new temperature, Celsius. Or it's going to say a temperature value or scale, one or the other. So you're going to have 2 combinations. One with 2 parameters for the 2 instance variables. That's number 3. And the other one's going to be the 4th one, which is going to be the default, which is going to set 0 degrees and Celsius. So that's where we come up with 4. One to set temperature, one to set scale, one that doesn't set anything at all, and one that says both together. Okay. And then we have some methods. And I give you the math, although you can probably figure this out. So you're going to have 3 types of methods. So you're going to create 3 methods. 2 methods that are going to return the temperature. One to return the degrees in Celsius. The other to return the degrees in Fahrenheit. So we got a little bit of, these are going to be 2 different methods. Use the 2 following formulas to write the 2 methods. Basic, I don't know, chemistry, I don't know, science. So, one, plus or minus 32 degrees. And then 3 methods to set the field. 1 to set the value, 1 to set the scale. So these are the accessors. Excuse me, these are the modifiers. So you have a couple of them to change from Celsius to Fahrenheit, from Fahrenheit to Celsius. You have more of them now to set the scale to Fahrenheit, set the scale to Celsius. It's everything you ever wanted to know about temperature all in one class. It's actually a fairly feature-rich class. And then you're going to want a comparison method. So this is going to actually show you a little bit about the string class and how to compare strings or how to compare numbers. So the comparison method is going to have two parameters. Both of the two parameters are objects of the temperature class. So now you're looking at comparing objects, which is interesting. And in the next part of the lecture, I'll show you a little bit more about object comparisons and stuff like that. Method should return an integer, so 0 means that the two temperatures are equal, 1 means that the first temperature is higher than the second, -1, the second one's higher than the first one. So, you have a little academic freedom to change this around, make it any way you want it. You can make a different scale if you want, come back true or false, I don't know, whatever you feel is necessary. And now you're going to create a driver program, so you're going to have two files. You're going to have a temperature class, you're going to have a driver program. You want all of this functionality in the temperature class. You don't want to put this in your driver program, which kind of demonstrates the use of how to create that class with all the functionality. So the driver, you also need to write a driver program, and you can call it the driver class, you can call it my driver, main, whatever it is you want to call it. And it contains a main method, as we've seen before. You can look at hello world, it has a main method, takes on parameters, we just saw how to do that. Make sure to use each of the constructors, so you're going to exercise it. And it seems kind of tedious, but you have to like make, I don't know, 4 instances or how many constructors you have to make instances for each one of them, essentially. And then just play around with them. Have this instance talk to that instance, to do a comparison or something. And there are 9 of them. Okay. And then here's how the syntax works. Design the driver program in any way that you want. Then run the program. If you don't provide any parameters in the command line, the program prints out the information required, but if you directly, or like maybe some instructions. So you want to do a little bit better error checking than what I just showed you, actually. 2 strings to describe the temperature. We have a C or an F, so after the Java program name, you can output 0, 1, -1 to show the equality and the inequality. You can design this any way you want. The example here, I was trying to show it out, is how to take on the information from the command line arguments and parse it out. We've seen how to do that. Actually, there's a million examples online. I'll show you that as well. You're going to need to use the 2-character, 2-double, 2-float to take the string argument from the command line and turn it into and assign it to a value of a variable that's of integer of a float value. And hint on the bottom here, get the command line argument string. They're strings. You need to convert the parts. So check the Java documentation for string class. So the purpose of the assignment is kind of get you to familiar, because strings are used a lot, actually, in Java. And then check out the float class, the double class for the conversion. And then here we have submit your .java source code files as your assignment submission. I don't need the .class files. Don't need that at all. Don't need any documentation either. One thing you probably have noticed, hopefully, maybe not, is my documentation. There's no internal documentation. So this is not a how to program in Java course. It's an object-oriented design course. But if you want to put your own header on the top of the file, this is program number 1 by so-and-so on this date for this class, year, and your biography information, whatever it is you want to put in that file is perfectly fine. If you are familiar, if you practice good source code writing, you already know you're supposed to put some comments in there, at least your name maybe on the assignment. Keep in mind that what you want to do is probably zip these 2 files together, because if you try to upload them to the I2 database, it will only take 1 file. So make sure, keep that in the back of your mind. What you want to do probably is go through these assignments, is just save them. Put them on a thumb drive, save them on your hard drive or something, and just zip them together and just call it assignment 1. So that when you're ready, you got it. You just turn it in, submit it. Any questions on that assignment number 1? No? The brand new people are like overwhelmed. Existing people are like, oh, what else are we going to hear? Maybe something new I haven't heard of before.
What's the due date for this assignment?
That's a good question. the very last day of the class. It's not really, okay, so the due date, in the syllabus I've got what you should be working on in terms of a natural flow of when you should be able to do certain assignments. As an example, whoops, I think I just ended, or I'm in the middle of a lecture 2 or 3 or something, probably 3. No, 3. I'm starting 3, if I remember that right. So when you get done with lecture 3, you should theoretically be able to do assignment number 1, which is one I just showed you. And because in the next few minutes I'm going to talk a little bit more about constructors. And I'm actually going to talk about packages and stuff like that too. And then we're going to hit all the way through lecture 4 today, which is going to take us pretty much even with the day class for this week. And so then you probably could do assignment number 2 as well. And then you're going to have your next class session for the weekend program in between assignment 2 and assignment 3. Because next time you come here to ITU, I'm going to give you the midterm, and I'm going to talk about assignment number 3. So theoretically, within the next month, you should be doing assignment 1 and 2. And assignment 2, we'll take a brief look at it, is about inheritance. Actually, I'm going to talk about inheritance and cover inheritance before you leave today. So you could actually do both. We haven't started interface design, interface classes yet in the day. So that'll be a topic for next week. So. But that was a good question. Nothing is due until the very last day of the class, technically, but you don't want to wait till the very last day. In fact, the assignments sort of build on each other, so you can kind of like figure out, learn more if you do them as you go through the course. So, any other questions? That was a good one. Nope. Okie dokie. And you're like, what are we going to do next? I think I have that lecture started already. Oops, not that one. Not that one. Not that one. I thought I had it up. PowerPoint is what I want. There we go. All right, so lecture 3. So we started at 12:30, 1:30. It's a good time for a 10-minute break if you guys want it, or I can continue. Sure? Okay, 10-minute break. Then we'll start lecture 3. Okay, so take 10. So we come back at 1:57-ish. 2 o'clock. 2 o'clock. 2 o'clock.